Chapter 1, Time Value of Money. In this chapter, you are going to learn the calculations of the time value of money, and you should know what a net present value means, and what is the difference between nominal rates of return and effective rates of return. Number one, now you're going to learn how to calculate the time value of money. Before we go on, you should know the meaning of time value of money. It refers to the value of money at different times. We split these four words into a complete sentence. Time value of money means at different times. Value of money. You should know that the value of $100 today is different from that of $1 1 year later. You see, there are two possible reasons for this. One is investment returns. Just like the following, you put $100 in your pocket without investing in useful tools. With useful tools, you see that this amount, just like the $100 note at the end of the year, will become smaller in value. That means the $100 note at present is not equal to the value of $100 notes at the end of the year. It's just like an inflation. Okay, you see the picture. Inflation. When the economy suffers from inflation, it means the fat boy will become thinner, while the balloon gets bigger. Okay, so inflation means some part of the economy will reduce its purchasing power. So you should know more about inflation in economics. Remember, when inflation prevails, the purchasing power of money will decrease. All right, let us look at the return. First one, investment returns. $100 today can be reinvested and earn interest. For example, you invest $100 in 2013 and get a $5 interest return 1 year later. Of course, if you do not put that $100 in your pocket, but put it in a bank, you'll earn interest from the bank. As a result, you'll have $105 at the end of the year. That means in 2014. As we make use of the following formula, okay, $100. What we mean is principal times 1 plus 5%. This 5% is the investment return. In this case, interest rate offered by the bank. The second part is about inflation. I have mentioned that inflation decreases the purchasing power of money. Look at these pictures. If you spend some money to buy an apple, after a while, in a years of time, for the same apple, you cannot buy with the same amount of money. You have to spend some more in order to buy the same amount of apple. Let's say for the same meaning, now. Some years before, you spent $5.99 to buy a big hamburger, while now you can this amount $5.99 can only buy a smaller size of hamburger. That's what inflation means. It means that the purchasing power of money, in this case, $5.99 decreases. That means you cannot buy the same amount of hamburger. Same size of hamburger from then and now. So it works. Hamburger costs you, say for example, in here is $10 today, but you cannot buy it for $10 1 year later if the restaurant increases its price. That's what inflation means. Okay, coming up, we should know the meaning of future value. Future value, in short, FV. Okay, future value refers to the value of money in the future. Very simple, just like the arrow. Okay, now we call it present. 1 year later or sometime later, we call it future. The concept of future value is useful, okay, in estimation of our future income and help us to make investment decisions. It's very important to know that our future value can help us to make investment decisions. So you should have a good memory of this now. Okay, let us look at this example. Okay, Mr. Wong deposits $100 in a bank for 1 year. The bank offers an annual interest rate of 5%. Just like here, the picture, you are Mr. Wong and you go to the ABC Bank to put $100 to the bank, to a cashier of the bank. The cashier tells you that the bank offer 5% interest. That means you may get back the principal and interest 1 year later. This interest is what we call investment return. Now, for future value, we're going to see this blue line. We call it timeline. 0 means at present. 1 stands for 1 year later. We are going to calculate the question mark. This is the future value of this $100 note. We will make use of the formula FV is equal to P. P stands for principal times bracket 1 plus R. R stands for interest rate. And we look at the example of Mr. Wong putting his $1 note in the ABC Bank. We substitute P stands for $100 and R stands for interest, 5% interest offered by the bank. Therefore, the future value is equal to 100 times bracket 1 plus 5%, as is equal to $105 in 1 year of time. Okay, quick quiz. Name 2 possible reasons that explain why the value of money is different over time. Do you remember these 2 possible reasons? Yes, one is investment return and the other is inflation. Both starting I. Okay, I stands for inflation and investment returns. Second question, calculate the future value in 1 year of time if the principal is $1,250 and the interest rate is 7%. We make use of the formula 1,250 times 1 plus 7%. That means 1.07. Okay, is equal to $1,337.5. Let's go to C, compounding. What compounding means is the process of calculating the future value over more than one period. It's very important to know more than one period. It is because the interest received in the first period will become part of the principal for the second period, and so on. So you should memorize this sentence. It's very important to answer questions when you are asked about compounding and give reasons why the interest due to compounding is more than due to simple interest. Okay, let us look at example. Calculate the future value for multiple periods. Case 1, deposit for 2 years. We mean multiple periods. 2 years is an example for multiple periods. Okay, Mr. Ho deposits $1,000 in a bank and annual interest rate is 5%. After 1 year, you see this bomb. Okay, this bomb, it means it's very important for you to know it. The concept is very important for you to know about compounding. Okay, Mr. Ho does not withdraw the money. Remember, for in these 2 years of time, Mr. Ho does not withdraw money, including the interest, and leave the interest together with the principal for another year. So you ask how much Mr. Ho will have 2 years later. So for compounding, you should remember that interest will not be taken away by the investor, okay, or depositor, and interest will come with the principal for another year, and so on. So let us look at this case. For the first period of time, from the present time, 0, to year one, at the end of first year, we make use of the formula. Future value is equal to $1,000 times 1 plus 5%. At the end of the first year, you can get $1,050, okay, together with the interest $50. So it will be the principal for the second year in green color, okay, in green color. That means the principal becomes bigger than the original one, $1,000. So getting this, having this $1,050, $1,050 principal at the end of the first year become the principal for the second year. Interest, of course, will be more than the interest in the first year. Okay, you remember this very important point. Interest received in the first period will become part of the principal for the second period. So the first part, I've mentioned it. The second time, the second sentence, we calculate how much Mr. Ho will have 2 years' time. The future in green, the future value for the first period becomes a principal for the second period. Please remember it as a tool for you to answer questions. So making use of formula, the future value of money for 2 years will be, future value is equal to 1,000 times 1 plus 5%. Those part in yellow means the principal in the second year, okay, at the beginning of the second year, okay, times another 1 plus 5%, which will be the amount at the end of the second year. So we group together 1 plus 5% into power 2. Power 2 is equal to $1,102.50. So in this case, you see the total of the interest when you're making use of compounding is more than simple interest as a result of the initial $1,000 investment. Okay, we summarize the formula for multiple periods. FV is equal to principal times 1 plus R to the power n. N stands for the number of period. The number of period. Let's come to know the factors affecting the future value. That means what are the factors which will increase the value or the future value? So you see the formula, future value is equal to principal times 1 plus R to the power n. There are 3 variables. One is principal, another one R, interest rate, another one is n, stands for number of periods. So all these 3 factors will affect the future value. Let's go to case 2, quick the principal. Say, for example, from $1,000 to $1,500. Suppose Mr. Ho now deposits $1,500 instead of $1,000 in ABC Bank, and the annual interest rate remains unchanged at 5%. Again, you are asked how much Mr. Ho can get 2 years later. Okay, for the same formula, you just only change the amount of principal from 1,000 to 1,500. So here, the future value becomes $1,653 times 75 cents. Just like this part, we change from $1,000 to $1,500 at the beginning of the year. So of course, every part of the amount has been increased. So case 2 indicates that a greater principal has a greater future value. Let's go to case 3, higher interest rate. Let's say from 5% to 10%. Mr. Ho deposits again $1,000 instead of 1,500. Okay, we keep the principal unchanged, but the interest rate paid by the bank increased from 5% to 10%. So you see that the formula remains unchanged, except that the interest rate change to 10%. Making use of the calculator, we find that the future value is $1,210. Of course, in this case, it indicates a higher interest rate has a greater future value. Very simple concept. Okay, next, greater number of periods. Say, for example, from 2 years to 3 years. Let's say the principal remains unchanged at $1,000 and the interest rate again remains unchanged at 5%, but it's the whole deposit for more years, from 2 years to 3 years. So changing the n, okay, the figure n from 2 to 3 to the power 3 now, the future value has increased to $1,157.63. So you see there is one more timeline in pink or in purple. So the conclusion is that it indicates more periods have a greater future value. Okay, let's summarize into these three factors. PRN, principal, interest rate, number of periods, will affect the future value. Okay, let's go to the quiz. Ms. Wong deposits $100,000 in the bank and the annual interest rate is 2.5%. How much will she get 2 years later? Remember, some students do not know how to change percentage into decimal places. Say you see the numbers in yellow box. 2.5% is equal to 2.5 over 100. So we turn the decimal place leftward to 2 places. Okay, we'll see that it becomes 0.025. So formula again, FV is equal to P times 1 plus R to the power N. We put all those variables into the equation. Okay, P stands for 100,000, R stands for 0.025, N stands for 2. We find this figure. Another one, calculate the future value in 3 years' time if the principal is 9,000 and interest rate is 7%. Again, P here stands for is 9,000, R stands is 7%, N is 3. Okay, it's a very simple calculation. Okay, this question is a little bit tricky. Let's look at it. Suppose you deposit $3 million in a bank with 6% per year. How many years do you need to purchase a flat for $3.5 million? You should know which one of them belongs to present value, which one of them belongs to future value. The first sentence implies that this $3 million is the present value because you deposit now and get $3.5 million in order to buy a flat after some years. So check it out. The future value is 3.5 million. So we make use of the formula. 3.5 million is equal to 3 million times 1 plus the rate, okay, 0.06 to the power n. In this question, it's a little bit tricky that you do not know how to find n. So you rarely see these questions in multiple choice, short questions, except that you'll be asked in multiple choice questions by substituting A, B, C, options A, B, C, D in this equation to see which one matches close to $3.5 million. All right. But in mathematics sense, like the calculation in yellow, you can make use of log, L-O-G, log, to calculate it. Okay, I just give it for reference. If you are interested, you encounter it in max. I do not know if you see it in M1, M2, or in simple mathematics. Okay, it's just for your reference. After teaching what future value is and the calculation of future value, we now go to present value. Okay, present value is the current value. Current value means today's value of future money. Future money, just the money you need for retirement. You say, for example, you need $5 million in your retirement at your retirement age. You should tell yourself how much now you should deposit in order to get that amount for retirement. Okay, this is what present value means. It is the amount needed today to grow into a specific future value in the future, just like this. The present value can be calculated as follows. We'll use this formula. Present value, because the present value should be smaller than the future value, so the factor 1 plus r to the power n should be the denominator. Okay, let us look at the example. Ms. Smart is going to get $10,000 1 year later, and the interest rate is 7%. What is the present value of this $10,000? Now, you should know that this $10,000 is the future value. You are going to find the present value. Of course, you should know that the present value should be smaller than $10,000. So the factor 1 plus 7% should be put in the denominator. Just like this. $10,000 over 1 plus 7% to the power 1. We mean 1 year later. Okay, so the value is smaller than $10,000. We get as 9,000 so and so. So a given future value is used to find the present value. This process is called discounting. We look at this picture. The present value, you see the coins together with the banknote amount is smaller than the future value. So we make use of compounding. Compounding is a factor 1 plus r to the power n to calculate the future value. When you are given the future value, you want to find the present value, we use discounting. This is a process to find the present value. When we use discounting, we use factor 1 over 1 plus r to the power n. It's just the opposite to compounding in order to calculate the present value. Remember this picture together with the factor. If the number of periods is more than 1, the process is called multi-period discounting. Suppose you want to get $1,000 in the future, how much do you need today? The concept of present value and discounting can help us to find the answer. Let us look at case 5 example. Mr. Lam wants to buy a watch which costs $15,000 in 3 years' time. You should identify this amount, $15,000, as a future value. So he wants to make an investment to save for the watch. You should note that he wants to make an investment to save. It means you are asked to find the present value. Okay, the present value of $15,000. So we make use of the formula. $15,000 over discounting. Okay, discounting 1 plus 8% to the power 3. 3 years of time. So we find 11,000. So okay, case 6. Mr. Jen plans to join a study tour which costs $10,000 1.5 years later. Okay, you again to identify this amount, $10,000, be a future value, be a future value. So you are asked to find the present value of the investment plan, which offers an interest rate of 5% per year, compounded semi-annually. You should note that semi-annually. Okay, how much does he need to invest today? So we make use of the fraction, future value on the top, $10,000. Down below, the denominator would be 1 plus 2.5y. because the annual interest is 5%, but it is compounded semi-annually. So we divide 5% by 2, we get 2.5%. But how can we come up with to the power of 3? Because the period, look at the period in blue. Mr. Chen wants to get this amount 1.5 years later. But when the investment was compounded semi-annually, that means for every year there are two periods. For every year there are 2 periods. Okay, that means 2 half-year investment. So 1.5 times 2. 1.5 times 2 is equal to 3. That means altogether we have 3 periods. 3 periods. Okay. You should note this when calculating the present value. So the answer is 9,000 so and so. Number 6. Calculate the present value if the future value in 2 years' time is $2,250 and annual interest rate is 7%. Very simple. On the top, we put $2,250. Down below is 1 plus R. We look at it, okay? 7%. We use 7% because we use 2 years time. Okay, well we have not mentioned about semi-annually, quarterly, monthly, so and so. Okay, so we make use of 7%, and 2 years time we just put 2. Okay, to the SA index. And for 7, calculate the present value again. $6,000 is 3 years time if the annual interest rate is 9%. Very simple. So again, 6,000 on the top, 9%, 3 years of time. It gets 4,000 so. Oh, a little bit difficult. If Mr. Wong wants to buy a watch which costs $100,000 1.5 years later, how much should he spend now on an investment plan that offers 3 years, a 3% interest return per year? Remarkably telling you that it was compounded semi-annually. So we have a change for 2 figures. $100,000 remain unchanged as principal, while the percentage, the rate should be divided by 2, and the number of periods n has was doubled. Okay, doubled because look at this, 1.5 years later, semi-annually. Semi-annually means for a year there are 2 periods. So we make use of 2 times 1.5. 2 times 1.5. That means we get the number 3. All right. Okay, 3. Mr. Lee has a 400 gift check. He can withdraw $400 now or withdraw $450 1 year later. Suppose the annual interest rate is 2%. Which option should Mr. Lee choose? So I've told you that this chapter can help you to make decisions. All right. Okay. You're facing 2 options. Okay, $400 now or $450 in 1 year of time. Okay, taking into account the present value of $450 with the interest rate of 2%, we try to find the future, the present value of this amount, $450. So we make use of the formula 450 over 1 plus 2%, 1 year. Okay, 1 year power 1. So we get $441. So we see that this amount, the present value, is more than $400 to be withdrawn now. So Mr. Lee should, when making a decision, okay, Mr. Lee should withdraw $450 1 year later. He should be patient to wait in 1 year of time. Now we go to another subtopic called net present value. Net present value is different from present value. Okay, of course, we have an additional word called net. Net means less. Okay, look at the words in yellow. Okay, shaded by yellow color. Net means less or minus the initial investment. Okay, look at the definition of net present value, or we call it NPV. NPV is the present value of a series of cash flows, less or minus the initial investment. Initial means at the beginning. Okay, at the beginning. The concept of NPV is used to determine whether the investment project is acceptable. Look at the pictures down below. You see tunnels, you see airport. When making decisions, if it is advisable or acceptable to build a tunnel or a new airport or runway in the present airport, well, we should make use of the net present value to calculate. Okay, to calculate if the net present value is positive or negative. Okay, if it is positive, we go on to invest. If it is negative, stop the project. Okay, look at this. The calculation of net present value refers to finding the difference between the present value of series of future income flows and initial investment. Look at this. Say, for example, if the initial investment of the tunnel very cheap, okay, is 3.5 million. So we use negative to show that the initial investment is a kind of cash outflows. Cash outflows, okay? That means we pay cash in order to build this tunnel. But this tunnel will benefit the economy by getting $1 million after 1 year, another 1 million in the second year, in another 1 million for the third year, another 1 million for the fourth year. Okay, let's stop here. Okay, say for example the tunnel can contribute to the economy by 4 years of time, contributing 1 million, 1 million, 1 million, 1 million in 4 years of time to the economy. But if you are specialists, okay, or professionals when calculating if the project is feasible or not, please do not just add all those 1 million. That means 4 million together. Of course, you know, at the beginning of this chapter, you are talking about time value of money. Okay, that means $1 million after 1 year is different to the another 1 million at the end of the 4 year. Okay, fourth year. So we should find the present value of every cash inflow, $1 million. Okay, to compare with this cash outflow of $3.5 million. Okay, remember this picture. Before we go on to a more difficult question, let's look at this simpler question. Suppose there is a proposal. Mr. Chen pays $9,000 now and receives $10,000 in 1 year's time. If the annual interest rate is 10%, should he accept the proposal? You are Mr. Chen. You sit in front of the manager telling you that you pay $9,000 now, and the manager in purple suit will give you $10,000 1 year later. So you should make use of scientific calculation to decide if it is profitable for you instead of just an emotional choice. So your decision should be with reference to the present value of $10,000. If the present value of $10,000 is higher than $9,000, then it is more profitable for you to take the proposal. Of course, opposite. Okay, if the present value of $10,000 is lower than $9,000, it is advisable not to take the proposal. So you are going to calculate, okay, to find the difference between the present value of this $10,000 future value and the initial investment, $9,000. We make use of this formula, okay, use this formula. Okay, remember it, okay, net present value is equal to all present values minus I. I stands for initial investment. So you have learned that the present value can be calculated by use of the formula future value over 1 plus rate, interest rate to the power n. We substitute the figures. A future value $10,000, rate 10%, and 1 year later, initial investment is $9,000. So we put all these figures into the formula. We'll see that the figure, the net present value is positive at $90, so 9.91 cents. So according to what we have learned, this is a positive net present value. It means it is advisable to take this proposal. We can also make use of a table to calculate it instead of the calculation in horizontal form. So you see the left side is year 0. That means at the beginning, the cash flow is negative. Negative means cash outflow. It should be the initial investment. So the present value is again same as negative $9,000 because it is year 0. It should be the present value. Okay, no change. For year 1, the cash flow is $10,000. But after making use of the formula above, you'll see the present value of $10,000 together with the interest rate of 10% will find the present value as $9,090. So we sum these two figures because these two figures can be compared and calculated with each other because they are on the same level, okay, as year 0. So we can just sum up these two figures and find the positive net present value at $90.91. We are going to learn the relationship between the future value and net present value. A higher future value will increase the net present value. Suppose there is a proposal. Mr. Chen pays $9,000 now and receives $20,000 in 1 year's time. If the annual interest rate is 10%, should he accept the proposal? Again, we're going to use the formula on the right hand side. Future value is $20,000. R stands for 10%, N stands for 1, I stands for 9,000. So we put together these figures, we'll find that the net present value, it should not be present PV, it should be NPV, okay? Should be $91,181.82, a positive figure. This new present value of 9,000 so and so is larger than the original net present value of $90 so and so. Of course, we should accept this proposal. The higher future value will increase the net present value. Look at this. For the year 0, negative 9,000 remains unchanged. While year 1, when we increase the cash flow from $10,000 to $20,000, of course, the present value will increase as well. So the present value increase a lot when compared to the original $10,000 cash flow in 1 year's of time. We are going to look at the relationship between interest rate and net present value. The conclusion is a larger interest rate lowers the net present value. Suppose there is a proposal, Mr. Chen pays $9,000 again now and receive $10,000 in 1 year's of time. Again, the same, okay? But the interest rate changes from 10% to 20%. That means there is an increase in annual interest rate. Should he accept the proposal? Look at the formula again. You see R was on the bottom side, okay? On the bottom side. It means the relationship between net present value and R, interest rate, would be in the opposite direction. That means when R increases, net present value will decrease. Look at this, NPV, again, not PV, NPV, substitute all those figures, $10,000, $9,000, and now 10% becomes 20%. So it becomes negative, negative 600. And so the conclusion was that Mr. Chen should not invest in it. So we can look at this from why when we change the 10% to 20%, it means that the investment return of Mr. Chen by will be higher, for an alternative investment other than this deposit in the bank. So interest rate is a very crucial factor which affect the net present value. You have been told that a negative NPV indicates that the proposal is not worth taking. If the net present value is equal to 0, it means it is indifferent for the firm to take the proposal or not. Indifferent means no benefit or no loss. You should make a decision with reference to other criteria. Don't just look at the figures. In real cases, we should look at a lot of factors other than the net present value. Okay, this is the summary of what I've told you, that the net present value and the interest rate have a negative relationship between each other. You see that for year one, from cash flows, $10,000 cash flow, when making use of the interest rate of 20%, it becomes $8,333. And so that means there will be a decrease in the present value. So the net present value becomes negative in this case. Okay, the third, we are now looking at the relationship between initial investment and NPV. Look at the picture below. You see it is the Hong Kong-Zhuhai Macau Bridge. It's a grand project for these three places. You spend a lot of money, okay, investment to build this bridge. So if initial investment becomes higher than what expected, you will lower the net present value. It's a very simple concept, right? Okay, let us look at an example. Suppose there is a proposal, Mr. Chen pays 9,500 now. Look at this. The cases before was $9,000 only, and now we came to $9,500 and receive the same amount, $10,000 and 10%. Should he accept the proposal? In this case, you'll see the initial investment becomes higher than before. Okay, putting all these figures into the equation, $10,000, 10%, year one, okay, but the initial investment becomes 9,500. Of course, it is a negative cash flow, or we call it a cash outflow. So because of the negative value is greater, so the net present value becomes negative in this case. So using a table to calculate it, you see year 0 from 9,000, negative 9,000 to negative 9,500. So originally we have a small amount of positive net present value, $90, but now it becomes negative $409. Look at the case. If the net present value of a proposal is positive, the company should take the proposal. Is it correct? Yes. B, discounting is a way to calculate future value. Okay, is it correct? Calculate future value? No. Okay. The answer should be present value. 10. Net present value is the future value of all cash flows less than the initial investment. Right? It should be less, but the wrong things was the future value of all cash flows. It should be wrong. It should be the present value of a series of cash flows. Okay, present value instead of future value. So the answer is false. Okay, look at the question to calculate net present value in multiple periods. Suppose company A is planning to purchase a set of equipment which costs $20,000. The manager expects that this equipment will generate cash flows of $10,000 in the first year, $20,000 in the second year. The annual interest rate is 10%. Should the manager purchase this equipment? Okay, you see, those figures in blue should not be just added together because the value in the first year is different from the value of money in the second year. We should not just add $10,000 and $20,000 to become $30,000. Wrong, okay, wrong here. So we make use of the formula by calculate the present value of $10,000 and $20,000. Okay, remember when calculating present value, the factor should be on the bottom. Okay, at the bottom. Okay, I mean at the bottom, 1.1 and 1.1 to the power 2. Okay, minus the initial investment, $20,000. So the net present value here is $5,619. So it is positive. So it is advisable for the manager to take this project or purchase this equipment. Using the table to calculate the net present value, we can use this form. Year 0, negative $20,000. First year, cash flow $10,000. Year 2, cash flow $20,000 to become 9,000, 6,000, and so. Okay, we sum up all these figures, we become a positive figure, 5,600. So net present value can be calculated by adding all the discounted future value minus the initial investment. We should know this: discounted future value. Discounted future value. We can also use the following formula. NPV is equal to future value year 1 over 1 plus R to the power 1 year 1. Okay. Next year 2. Next year 3. That means if the cash flows can be generated for many years, so we use ... to represent a series of present value of the future discounted future values. This is called with discounting. Okay, or we may use this technical term summation. This like a E is summation. N stands for year period 1, year 1. T stands for the end of the period. Okay, usually you will not use this formula in BFS. Demonstration corner. Calculate the net present value of multiple periods. Look at the case. Firm B plans to purchase equipment which costs $500,000. This is an initial investment. Initial investment. The equipment is expected to be used for 3 years. Okay, Firm B will need to pay $10,000 for maintenance before selling the equipment for $30,000 at the end of the year 3. So at the end of year 3, there should be a cash outflow of $10,000 for maintenance, but we have a positive $30,000 by selling the equipment at the end of year 3. But remember, this amount, $30,000 at the end of year 3, is not the same as $30,000 at present. Okay, remember this. So you have to discount this amount, $30,000, to the present value. Okay. The last sentence. Equipment can generate a cash flow of $180,000 per year. So look at this. The cost of capital is 5%. So the investment decision is whether Firm B should purchase the equipment or not. We may use the table before. Year 0 cash flow negative 500,000. Remember, this is a cash outflow, so we use a negative to represent negative outflow. Year 1, 180,000. Year 2, again $180,000 cash inflow. Year 3, again $180,000 inflow. But remember, you are told that the company has to spend $10,000 for maintenance, but after the maintenance, the equipment can be sold for $30,000 at the year end of the year. So just put these figures together. But remember, never add these figures together. Never add these figures together. Remember, all those figures in different years have different value of money. we have to discount. Remember, we have to discount the future value to the present value. Okay. So every figure should discount 1.05 to the power 1, next 1.05 to the power 2, next 1.05 to the power 3. Remember, we should minus the initial investment, that is $500,000. So we get a positive figure. So firm B should purchase the equipment, and the reason is the net present value is positive. Coming up, we are going to distinguish between nominal and effective rates of return. So first look at nominal rate of return. In case one, when Mr. Ho deposits $1,000 in the bank offers an annual interest rate of 5%. This rate is called the stated interest rate, or called declared interest rate, declared by the bank, okay? Declared interest rate, which is also known as a nominal interest rate, or nominal rate of return, NRR, nominal rate of return. But for effective rate of return, interest can be compounded more than once during a year. The frequency of compounding represents how often interest is compounded. If the interest is compounded more than once during a year, the nominal interest rate cannot reflect actual return of an investment. The effective rate of return, ERR, will be used. Look at the case as an example. In case 1, suppose the interest rate is compounded twice per year. That means compounded semi-annually. So we'll earn an interest of $25 after 6 months. Let us look at the formula. $1,000 times 5% over 2. That means the interest is compounded twice a year. So the annual interest 5% should be divided by 2. Okay, the first half of the year, that means 6 months, Mr. Chen can get $25 as interest. And if Mr. Ho will invest, look at this word, reinvest some interest, $25, the new principal will be $1,025. Mr. Ho will earn interest of 25.63%. That means more than the interest earned in the first half of the year. All right, so we add together $25 in the first half of the year and $25.63 in the second half of the year. We'll see the interest will become higher. Mr. Ho will get $1,050 point for 63 cents. Rate of return becomes 5.06%. In this case, the effective rate of return, ERR, is the rate of return that includes interest reinvested during the year. Now remember this sentence. What does effective rate of return mean? It means the rate of return that includes the interest reinvested during the year. It can be computed using this formula. You see this bomb, okay? Bomb sign. That means you should remember it. R is equal to 1 plus R rate, interest rate per year, over K. K means number of periods compounded in a year. Okay, remember, in a year. Okay, to the power K minus 1. 1 means the principal. That means we take away the principal, we'll get the effective rate of return, the percentage. We're going to look at the different frequencies of compounding. Suppose you deposit $100,000 in a bank for 1 year. The stated, look at this, a stated annual interest rate is 12%. We can choose how often interest is compounded, annually or semi-annually. Which option will earn the highest amount of interest for this deposit? In common sense, you'll know that if the interest is compounded semi-annually, that means the interest earned will be higher. It's very simple. Okay, look at this table. You see, when the interest is compounded annually, that means at the end of the year, $100,000 will become $112,000 at the end of the year, with non-stop. Okay, no interest in between. Okay, but if the interest is compounded semi-annually, you see on the 30th of June, you first get interest from the principal of $100,000. Okay, and so we you will put the interest together with the principal for the second half of the year. Of course, because of the higher principal, the interest for the second half will become higher and more, okay, more than the interest which is compounded annually. You see, if the interest is compounded semi-annually, there will be $360 interest more than the interest compounded annually. Now you see this compounded annually, 112,000 minus 100,000, we get $12,000 interest. When interest is compounded semi-annually, the interest will be $12,360. It means that interest is compounded more frequently. The interest return will be higher. Let us look at case 9. Mr. Lee plans to join an investment plan. There are 3 plans. Which one should Mr. Lee choose to yield the highest effective rate of return? Plan A, 9% semi-annually. Plan B, 8%, a lower percentage, but more frequent compounding quarterly. Plan C, again, lower interest rate, but again, more frequent compounding. Okay, we do not know except that we make use of the formula to calculate the effective rate of return. All right, for plan A, we kept the image from a PowerPoint, last PowerPoint. You see 9% should be divided by 2 because the period is semi-annually. That means half yearly, okay? Half yearly. So 9% divided by 2 and the period increases by times 2. Okay, minus 1, that means minus the principal, okay, principal amount. That means we'll get a 9.2%. For plan B, ERR is equal to 1 plus 8% divided by 4. Why? Because interest is compounded quarterly. Quarterly means for quarters, okay, in a year. So we divide by 4 and we power 4 minus 1. So we get 8.24%. For plan C, 6% over 12 because compounded monthly, okay, instead of semi-monthly, okay, round here, okay, monthly 12, power 12, okay. You see rate is lower, okay, 6.18% only. We can conclude that Mr. Lee should choose plan A as the effective rate of return is the highest. The effective rate is useful in making investment decisions, just like plan A, plan B, and plan C, just like bank A, bank B, and bank C, which offers different rates to blur your decision. The effective rate of return gives a common ground for comparing the rates of return of different investment projects. It's very useful for investors. Okay, let us look at this example. Let's suppose the interest rate is 8% per annum. Calculate the effective rate of return if compounded quarterly and 2 monthly. Very simple. 8% means 0.08 divided by 4. Quarterly means 4. Power 4 minus 1 is equal to 8.24%. For monthly, divided by 12, the power 12 minus 1. The answer is 8.3%. You have a Hong Kong $1,000 deposit at Bank A and then at Bank B. Bank A gives you an annual interest rate of 7% compounded on a monthly basis. Bank B quarterly basis. Okay, you see which bank actually gives you higher rate of return. Very, very simple. Monthly means 7% over 12 to the power 12 minus 1. That means 7.23%. For Bank B, quarterly means divided by 4 to the power 4 minus 1. The answer, the ERR is 7.4%, which is higher than the ERR offered by Bank A. Another example, 2 savings plan with one has a higher effective rate of return. Plan A, 10% quarterly basis. Plan B, 9% monthly basis. Again, plan A, ER is equal to 10% divided by 4, means quarterly. Quarterly means 4 to the power 4, okay, minus 1. For plan B, 9% over monthly. Monthly means 12 to the power 12 minus 1. Okay, the answer is plan A. Okay, I hope you enjoyed this chapter. This is the end of chapter 1.